Welcome to another video on standard deviation in the descriptive statistics section. After this video, you will learn through clear visual and simple explanations what a standard deviation is, how to calculate it manually and using functions in Excel, why it is divided by n-1, and how does it differ from variance. Imagine two classrooms. In both, students score on average of 75 on a math test. But in one class, everyone scored between 70 and 80. In the other, scores ranged from 40 to 100. Same average, very different story. That difference, it is called a standard deviation. Let's break it down and see why this simple concept is one of the most powerful tools in statistics. Standard deviation is a measure of dispersion and variability. It shows how much each value in a dataset on average differ from the mean. If they are scattered far and wide, the standard deviation is high. If your data points are tightly clustered around the mean, the standard deviation is low. Let's take a look at another example. Imagine we have 4 students in a sports team. A dataset shows the height of these 4 players. To calculate the standard deviation of their heights, we first need to find the arithmetic mean. If you are not sure how to calculate the mean, check out the video on arithmetic mean in our descriptive statistics playlist. In this example, the mean height is 172 centimeters. We want to know how much each person's height deviates from the mean. Based on the figure, the first person's height is 178 centimeters, which deviates 6 centimeters from the mean. The second person deviates 7 centimeters from the mean, the third 9, and the fourth deviates 10 centimeters. In general, people who are very tall or very short deviates more from the mean. Now, listing every deviation individually does not give us a clear picture of overall spread. For example, a dataset with 1000 values would have 1000 deviations, too detailed and hard to interpret. So we ask on average how far are data points from the mean. That is where standard deviation comes in. The basic formula is sigma x minus x bar divided by n. In our example, x indicates each player's height, x bar the mean height of the players, and n is the total number of players. But here is the issue. Positive and negative deviation cancel out each other and their sum becomes 0. To prevent cancellation problem, we have two options. 1. Take the absolute value of each deviation. 2. Square each deviation. Squaring is the standard method because it is mathematically convenient, it is sensitive to large deviations, it is easy to use in statistical inference. After squaring and averaging the deviation, which is called variance, for example, if data is in centimeters, variance is square centimeters, and it is less intuitive. We take the square root to return to the original units, making it easier to interpret. The small sigma Greek letter indicates population standard deviation. X is the height of the person. X bar indicates average height, and n is the number of people. So standard deviation is the root of the sum of a squared deviation divided by the number of people. It tells us how spread out the data is in the same units as the original data. In our example, the x bar or mean height of these 4 players is 172 centimeters. We sum all deviations from the mean and divide them by the total number of people, which is 4. To prevent the cancellation problem, squaring them. And to bring the formula back to the original unit, take the square root. So the result is a standard deviation, which is 8.15 centimeters. Why it is divided by n-1? Here is the million-dollar question. Why not divide by n? Why subtract 1? This is called Bessel's correction, and it's all about bias correction. When you calculate a standard deviation from a sample, in fact, you're estimating the population standard deviation based on a sample. To compute unbiased sample standard deviation, you divide by n-1 instead of n. This is because sampling always underestimates the variability in a population So reducing the denominator is supposed to offset this bias. But all of the ways to reduce the denominator, why have statisticians settled on n-1 specifically? It is statistically proved that other arbitrary offsetting value like n-2, n-3, and etc. underestimates the true population standard deviation. What is the difference between standard deviation and variance? Variance measures the average squared deviation from the mean, but squaring makes the unit messy. Scores in meters become variance in meters square. That is not very intuitive. You can't say the variance is 25 meters square, so what does that mean? Standard deviation comes to the rescue by taking the square root of the variance. Now you are back in the original unit, for instance, meters, dollars, exam point, much easier to interpret. In short, variance equals to the mathematical foundation, standard deviation equals practical, human-friendly measure. Think of variance as the blueprint, standard deviation is the finished building, ready to be understood and used. Calculating standard deviation by function and manually in Excel. In Excel, you can calculate the standard deviation in two ways, using a built-in function or doing it manually. Let's go through both methods. Method 1, using Excel function. Simply write equal stdev.p for standard deviation of the population. Bracket, select the data range and press enter. In our example, the result is 8.15 centimeters. Method 2, manual calculation. First, find the arithmetic mean, equal average, bracket, select the data range, enter. The average height is 172 centimeters. For more details, please check out the arithmetic mean video in our descriptive statistics playlist. Second, calculate deviation from the mean. Equal, select the first height, subtract the average. Because the average is the same for all data range, we lock this cell, press F4, enter. To apply to the rest of rows, drag down. Third, calculate the squared deviation. Equal, select the first deviation and square it. Enter. Drag down to apply to the rest of rows. Fourth, to sum all squared deviation. Equal, sum, bracket, select the data range and press enter. Finally, for calculating the standard deviation manually, equal SQRT, which stands for square root, bracket, select the sum of squared deviation divided by number of observation, which is 4 in our example. Close the bracket, enter. The result is 8.15 centimeters, which matches the previous result of Excel function for standard deviation. That is how you calculate standard deviation in Excel, both automatically and manually. Please don't forget to subscribe for more tutorials on statistics, Excel tips, and data analysis.